You attempted it?
Yes, sir.
What you got?
4.88
4.88. All right.
centimeter.
Let me try it out and see if I get that. So I'm not sharing. Just give me a moment. Let me share. All right. So using the sine rule, we can say the side over sine of the angle is equal to the next side over sine of that angle. All right. So before we do plug in any values, we just need to locate angles and the corresponding sides. All right. So for this angle 50, I'm going to call this angle A. Again, it doesn't matter if you called this one A or not, right? I'm going to call this angle A. And so this side is the opposite side. That's going to be my small a. And the same, I'm going to call this angle here B. And so the opposite side here is going to be my small b, which means that this opposite side is the side that I'm going to be trying to find, yeah? So let's then plug in these values into the formula. Small a, which is 4, which is the size of the side, 4 centimeters over the sine of the angle, which is 50, is equal to small b, which is what we don't know and trying to find, over the sine of the angle b, which is 70. So we cross multiply sine 40, no, not 40, sorry, sine 70 times 4 is equal to sine 50 times the small b. So plug into your calculators sine 70 for me and tell me what you get.
0.94.
Everybody got that? I'm going to double check it. All right, let me check it just to be sure. 0.94. So nobody is not working these questions? 0.94. Let me see. Sine 70. All right. I'm going to put 0.939 times 4 equals sine 50 times b. So 0.94 that number. 0.939 times 4 gives you what? 3.758. So all I've done is to just plug in 0.939 times 4 in the calculator. And then
This is 3.756.
3.75.
Not,
It's okay. The thing is that I just plug in sine 70. I didn't round it off. I just multiply it by 4. But it's okay.
but I'm saying that would be 3.756, not 78. That
No, no, no.
75. When I plug this in,
Mm-hmm.
I got 3.756
All right. And I'm telling you that the reason why you got
Yeah,
when I
that.
did the
it's the same thing.
multiplication.
3.756 I get when I plug
Yes,
in
when I did the
what it is.
multiplication. So it
Right.
wouldn't
And
be
I'm telling you
7.
that the reason you got that, it's not wrong. It's not wrong. Neither of them are wrong, right? This is the third decimal place, right? But the reason you got that is because when you put sine 70, you rounded off the answer, yes? Yes?
Well,
When you plug sine 70 into your calculator, you rounded off the answer, yes?
you take it down.
Who who answered me? Somebody else
Okay.
did say that them get that as well, right?
Okay. You change it.
All right, so nobody not answer me, so I'll move on then. Sine 50 What do you get for sine 50? Sine 50?
0.7660, but you let us put 0.766.
All right, you can put that. So what I was telling you just now is that you say like how you round it off until 0.766. When I plug
Yes.
it into my calculator, I don't round it off. It's all that long number that you have. I just multiply that long number
Multiply.
by
Okay.
the 4 over here. And that's why you guys got 3.756 and I have 3.758. But I'm saying to you that that third decimal place, it's not consequential. It doesn't matter substantively. All right, so don't worry about it. So we um end up with this answer here. So what we need to do now is to get 0.766 across the equal sign. And because it's being multiplied over here, when we carry it over, it's going to be divided. So we're going to have 3.758 over 0.766 equals to B. So when you plug in that in your calculator, what do you get? What answer you guys get?
4.9033 one long.
Okay, so 4.9, we say you get 4.903.
Yes.
All right, so I'm going to leave it at 4.9, right? Which is what I get. I got
Mm.
4.906, but it's all the same. It's not consequential at all. So 4.9 centimeter is your answer. No, yeah, because this is a side that you're trying to find. So that is the sign rule in a nutshell. We're going to work some more questions in relation to the sign rule, but so far, are there any questions? Any questions?
As long as they get to read up, like when you get it by the triangle, as long as they get to read there, as in the A over the B, the sign A, capital A, and it's
Mhm.
confusing there sometimes.
So the angle. So
If
what
you don't know to read it well, you
So what I have to
confuse it.
do is just to take it step by step. You see, just like when you see I do it right here, where I just choose an angle and I say, okay, what side is across from it? The angle is the big A, which is what you're going to put under this with the sign, and then whatever side is across from it, that's from the top. So you just have to just take it a step at a time. Now, if you're looking at it as a big thing at once, it may seem a little overwhelming, but it's just like what I do it right here. You do it like that, and you should be fine, one step at a time. All right.
Okay.
All right. So that's the sign rule for now. We're going to come back to it to work some questions. But we're going to just introduce you to the cosine rule and then we start working some questions for both, where you know going to have to decide whether you're going to have to use the sine rule or use the cosine rule, because in an exam situation they're not going to say use the sine rule to find. You are going to have to look at the you're going to have to look at the question, look at the triangle, and figure out which of the rules is most appropriate. All right. So let's now examine the cosine rule. So let's go again and say we have a triangle, similar situation as before. Oh, no, it's not going to work. I don't have enough space. All right, similar situation from before. I'm going to just label these angles. So I'm labeling ABC. And of course, since I've labeled that ABC, the side across from the angle is common A. The side across from this one is common B, and this one will be common C. Now the cosine rule, let me just tell you what it states first, and then we can have a conversation about it after. It says A squared equals to B squared plus C squared minus 2BC times cosine A. All right. So I know you may be thinking at this moment that, boy, this is a long formula, but don't matter if it's long or it's short, because guess what? Once you start working enough questions and you start using the formula, it becomes easy for you to use, right? Some things I want you to appreciate about this formula now, right? Because it's not just about swatting a formula. So when you look at this formula here, of course, the small letters as usual refer to the side. So the sides are these little, the lengths over here, A, B, and C. And of course, the sides are always in relation to an angle. They're opposite an angle. So if you've labeled this A, then it means the angle opposite it is the angle A. That matters because in the cosine rule, whatever you have on the outside here that you're solving for, the angle is what you have at the end here. Everybody seeing that? Yes, no? So
Yes, ma'am.
so that is critical for you to understand that if you're solving for A, the angle that you have out here in the formula is going to be cosine A, right? And then you have B squared, you have B, the B's and C's being multiplied and added inside the angle, inside the equation here. This equation can be written three different ways for each side and each angle of the triangle, right? So it's not just A you can find for. If we are looking at this triangle and calling this, making the formula based off this triangle, we can go again. We can say B squared, if we're looking at B, so we can say B squared is going to be equal to A squared plus C squared minus 2AC times cosine B. The B squared you're solving for, that side, the angle is what is in the cosine here, and the A's and the C's, the other two sides, are being multiplied inside the formula, yes? We can go again for the side C, and we can say C squared is going to be equal to A squared plus B squared minus 2AB times cosine C. And the single reason I'm doing this and going through all of this is for you to appreciate that whatever side you are solving for, which is what you have outside here, so that's a squared or b squared, that the corresponding angle is what is under the cosine here. And it's an easy way for you to go about appreciating the formula, right? So, and then the other two sides are what you have inside being added and being multiplied, all right? So now that you have an appreciation for what the cosine rule is, let us try and apply it. Now, before, when you were using the sine rule, if you didn't have two angles, well, you had to have two angles and a side, or two sides and the angle in order to work. And they had to be opposites, yes? Because based on how the rule was set up. Now, in this case, in the case of the cosine, it's different requirement. When I say requirements, I say it loosely. So let me just give you an example. Again, the best way to have you appreciate it is just to have you see it. So I'm going to delete two of these because in truth and in fact, you only need one. So let's just give you a triangle and then we can work from there. All right. So random triangle, and I'm giving this to be 60. This side is 5 centimeters, and this side is 4 centimeters. And I'm asked to find x right here. So if you look at this, you can't use the cosine, you can't use the sine rule like, sorry, you can't use the sine rule that you just learned, because you don't have enough information to use the sine rule, right? So you have to use the cosine rule. So what we can do now, the formula says a squared equal b squared plus c squared, blah, 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 cosine a. So whatever side I'm going to make my a, I need to make sure I have that formula. I have that angle, sorry. So this is the one I'm going to make this side that I'm solving for. This is going to be my A, right? And I have the angle right here. So I can put that in the formula. And then I have these two sides that I can plug in as B and C. And of course, it doesn't matter which one is B and which one is C. Doesn't matter at all, all right? So let's see how the formula works now. So, so A squared equals to B squared plus c squared minus 2bc times cosine a. So I've decided that a squared is this here. I'm trying to find it. So that's my a squared, b squared, 4 squared, that's that side over here, plus 5 squared, that's the next side, minus 2 times b was what, 4, times c, which is 5, times cosine of a. So, well, I have a, so let me just put in a, sorry. Cosine 60, all right? So a squared is equal to 4 squared is 16, 5 squared is 25, minus 2 fours is, 2 fours is what, 8, and 8 fives is 40. I hope that is right. 2 times 4 is 8. 8 times 5 is 40, yes. Times the cosine of 60. What's the cosine of 60? Cosine of 60?
0.5.
0.5. 0.5. So a squared is 16 plus 25 is 41, minus 40 times 0.5. That's 20. That's a half of 40. It's 20. A squared is equal to, this looks like 21, yeah? Yeah, 21, yeah. 41 minus 20 is 21. So a squared, that's what we're finding, is equal to 21. I don't think I have any more space. And so we have a squared, but we want a, so we're going to have to find the root of both sides. So a squared, root of 21, we're going to have a is equal to, what's the root of 21? Plug that in the calculator.
4.58.
4.56. So 4.5, what's happening? 4.56. That's 5.6, okay? So that is us using the cosine rule just now. 4.56. So all we did, we looked at the equation, we looked at the triangle, saw what information we had, and figured out, what we're going to use. All right. Let's work another one. Any questions so far? No questions? All right. So let's work one more cosine, and then I just give you random ones and you're going to have to decide. All right. So this is another cosine one. All right. So we're practicing for the cosine rule now. So this is another one. So we look at it, and again, everything is in relation to the sides. So we have this is we can call this A, big A, and it's important for us to identify that angle because then this becomes a small a. So we know that we have that small a there and that big A to go in the cosine with the cosine right here. And then we can call any of these anything. They don't matter because they don't have any angles with them. So it doesn't matter what we call them, all right? So we're trying to find this this angle here. So let's go ahead and find the angle. Let's plug these values in the formula. So small a we know to be 5. So we say 5 squared, and this is a formula I'm using. 5 squared, let me write it back. Let me not shortcut it because a squared is equal to b squared plus c squared minus 2bc times cosine a. All right. So a squared we said was 5. So we have 5 squared equals to b squared, which is 4 squared plus 3 squared minus 2 times 4 times 3 times cosine a. That's the cosine a that we want to find. All right. So this is 25. 5 times 5 is 25. 4 times 4 is 16. 3 times 3 is 9 minus 2 times 4 is 2 fours is what? 8. 8 threes is 24. Is that right? I hope so. 3 8 24, yes. Times cosine A. So we go again. 16 plus 9 gives us 25, I think, minus 24 times cosine A. All right. So we need to have a cosine A by itself so that we can find angle A. So we need to start moving these things across the equal sign, right? So 25 minus 24 is 1. So we can just move. So this is 1. Everybody seeing that? 25 minus 24. This is what I'm talking about. This is 1. So I'm going to move this 1 across the equal sign. So that's 25 minus 1. Something is wrong. Can't do that. Sorry. Give me a moment. What did I do? The wrong thing. I want to pause here. No. I want to pause this. Right. So I was saying this 25, this 24 here is being multiplied. So I can't carry it over like that. So I'm going to undo. I'm going to just undo this line. Delete. All right. 25. Give me a moment, please.
Okay, miss.
Recording. All right. So as I was saying, we've solved the mystery, so we can move on. Um, so going just as we were doing. So as I was saying, we can't carry over this 24 because it's being multiplied. So we just have to carry this over first. So 16 plus 9 gives us 25, right? 16 and 9, 25. So we have to carry this 25 across the equal sign, and we're going to get 0 because 25 minus 25 is going to equal to 0, right? So we're just working it as is, cost A. So we are just going to know this is being multiplied. So we're going to have to take it across and it's going to be divided. So we're going to have 0, which is this 25 minus 25 over minus 24 equals to cos A. Everybody following so far? Or everybody gone to sleep?
Yes, miss, so far.
Yeah. So 0 divided by negative 24, you plunge it in a calculator, it's going to give you 0, or it should. 0 divided by anything is going to give you 0, right? 0. So you have 0, where am I? 0 equals to cos A. So as usual, we want to get the A, which is the angle, so we have to carry over the cos. And when you carry over the cos, it's going to be the inverse of 0 equals to A. So plug in cos inverse 0 for me and tell me what you get. So remember, to get the cos
90.
inverse, you're going to have to do shift or second function and then you touch cos.
Got 90.
So you got 90. That is the answer. So this triangle is indeed a 90 degrees, a right angle triangle. The answer to for A is 90 degree. All right. So we have 4 minutes left on this meeting. I'm going to give you 3 questions or 2 questions, 3 questions to work, and then I'm going to do another one and just work those questions that we leave. We're not going to do another 40 minutes, all right? And we will pick up. We will pick up on Saturday. Everybody okay with that?
Yes,
Yes.
miss.
No.
Yes.
All right. So I'm going to give you just 3 triangles. And these ones, you're going to have to figure out whether it's cosine or sine rule that you're going to have to use, all right? And then I'll send another link. We'll work them out and we'll leave. We won't spend the entire time because we passed 9 o'clock already, all right? I'm a known I have to go work tomorrow. And me, of course. Yeah, work for the tomorrow as well. So let's go. So just 3 minutes. Just write them down as I'm writing them. All right. That's one.
Make it 8 centimeter at the bottom.
Yes. I need to work on my penmanship, it seems. All right, so those are your three questions, and just write them off for now, and then we'll come back and work them out. So you have to decide whether you're using sine rule or cosine rule to do these.